All right. Let's get on over here. All right, Jane has a question. Let's go. Hey. Stop. Let's go. You got time? Let's get going here. Jake's got a question. Alright, I'm going to do this here. Okay, so Jake, what's your question? Number one.
Pre-calculus semester 1 review, it has like parentheses P1, 2, 3, 4.
Yes,
Number 23, like where's my task?
Actually, you mean the one that talks about symmetry?
Yeah.
Okay, well, we have tests of symmetry. So our equation is y equals x squared minus 4. Now, this one is particularly easy because you should know what that looks like. That's a parabola whose vertex is a 0, -4. So what symmetry does that have? Y-axis. That has y-axis symmetry. Now, if you get an equation that you don't know what it looks like, then your test of symmetry for the y-axis, you change the signs on x. And if that simplifies to be the same equation, which it does, then you have y-axis symmetry. For the x-axis, all this is in your notes. So you can look this up and not take our review time, but change the sign on y, and that is not the same equation, so there's no x-axis symmetry. And then if I change them both, that will be for the origin, and that is not going to work out to be the same because it's going to be this. And then for the identity line, I switch the variables, and that clearly is not the same equation. So those are the tests of symmetry, all in your notes. If you can't tell, obviously this one we could tell right off the bat because we recognize the picture. All right? Who else found one question? Ronan?
It's on pre-calculus.
The same review sheet?
It might be, I didn't hear what he said, but
Yeah, it's just, we only really have one review sheet.
Yeah,
So.
number 2. Find F.
Find f of x minus 2?
Yeah. 4.
Okay. Well, remember, to find f of anything, what do we do?
Plug it in.
You just plug it in. So if you're finding f of x minus 2, you just plug in x minus 2 for all of the x's, FOIL it all out, clean it all up, and that would be your answer. Okay, Ronan?
Yeah.
Yeah, all we do, so this is a FOIL, distribute, collect like terms, clean it all up. Okay? All right, who else had a question about your review sheet? You guys were supposed to spend time on this the other day.
Yep.
Jake?
15.
15. I'll find g of f of x.
Oh, and well, you might as well do number 16.
Huh?
Can you use number 16 with that too, if you're gonna find G?
I know what g is.
No, but
I'm doing 15, the first one, okay? It says find g of f of x. That is actually exactly like Ronan's problem, because it literally says, take f and plug it into g. So f is 2x squared plus 7x minus 1. So I'm going to have 3 times 2x squared plus 7x minus 1 minus 2, because I'm taking the f function, this guy right here, and plugging it into g. And then I'll distribute, collect my terms, do all the, arithmetic.
and then number 16 was asking.
It says find the inverse of g. So g is 3x minus 2. How do we find an inverse?
Switch variables.
Switch the variables and solve for y. So it's going to be x plus 2 over 3 is going to be the inverse.
So -1 is pretty much saying find G.
That's your inverse notation. That isn't a negative 1. I mean, it is, but it doesn't mean anything to do with -1. It's the inverse notation. It means find the inverse. Okay? What else? Anything else? Who am I missing over here? Yep,
Number 20.
20, we got a box, it's 30 by 40, okay, we've done lots of these, do you remember anything about it, Vincenza?
Very little.
Uh-oh, okay, so
The volume included.
let's remember our exams tomorrow, so if we remember very little of something, what should we be doing as good students?
Office hours.
Ask a question.
No, we should be going back and looking at our notes, because we've done all these problems. This is not brand new. So that's what you guys need to do tonight. And the people who think this exam is easy are the people who have done that. Okay, you can't, oh gosh, guys, oh gosh.
This is a red flag.
These questions are making me nervous. All right, so our paper is 30 by 40. All right, I'm gonna make the box, okay. The equation for the volume of the box, length times width times height. Remember, the original paper was 30, but I took an X off each side, so 30 minus 2X,
Yeah.
40 minus 2X,
Yeah.
and X. Does that ever change? No.
No.
No, the only thing that's gonna change is those two numbers, which are gonna be given in the problem. And then the domain
15.
of the problem
Zero.
is gonna be 0 to 15, because our domain is always positive. It's X, I'm cutting out the corner, it has to be positive. And the maximum is half of this dimension. Because I'm taking a piece, I have the smaller dimension, I have the smaller one. I'm taking off a piece of each side of it. And then, to draw it, I need to just type this in on my calculator. On my calculator, this is calculator problem, so I'll type in that equation. In my window, this will be X min and this will be X max, automatic.
Stop talking.
Y min will always be 0, and Y max is gonna be some guess, I'll guess 1,000, I don't know. I won't know until I graph it. Okay, so now I gotta find my calculator.
Where do we get that 1,000?
I made it up. I gotta have a number in there. So I'm gonna type in my equation. 30 minus 2x, 40 minus 2x. And Shenja, you better be typing this in with me or I'm gonna be really mad.
I am.
Alright, 0 to 15, 0 to 1,000. I'm gonna get graph, oh, okay, so 1,000 isn't big enough, how can I tell 1,000 is big
You
enough?
don't see the top.
I don't see the top, and I'm finding the maximum, so it would be very helpful to see the top.
4,000.
I'm gonna go ahead and make this 5,000. You can make it whatever you want, as long as you see the top of that hill. I got it. Okay, so X min, X max, Y min, set. This one has to be flexible because you don't know how high you're gonna end up going. So, I've sketched it, it looks something like this. Okay? Now I need the maximum. What is the maximum volume of the box? So I will second calc, maximum, and then set my left bound, right bound, and take a stab at it there. And it looks like that is 5.657, comma, 3032.303. That is the maximum point of that graph. Now, the question actually says, what is the maximum volume of the box? So which of these two numbers do I want if I want the volume? I want Y. So it would be 3,032.303 cubic inches would be the maximum volume of the box. Now, what if I only wanted the box to have a volume of 2,000?
Plug in 2,000.
So, no, I don't, so a separate equation. So I go to Y equals and type in a second equation, 2,000,
And then do you take the first one or the second one?
both of them. And then I look for where they intersect. So I'm gonna find where they intersect. So I'm gonna find that point and that point. So here we go, second calc intersect. Looks like this one is 2.192. And the other one is oh, I got 10.
Yep.
Okay, so what does the question say? What size would the corners be to have a box with a volume? Well, the corners would have to be either 2.192 inches or 10 inches. The shape of the box would be different, but the volume of it would be the same. One would be like long and flat, and one would be tall and thinner.
Oh,
I'm not done with this one yet. What size would the corners be to have a box with a volume of at least 200 or 2,000? Well, at least 2,000 means 2,000 or bigger. So anything between that number and that number would have a volume more than 2,000. Yeah, whatever. And then question F, I already answered, the domain is right here. This is the domain, 0 to 15. Now that is important because if you graph this equation without any domain restrictions, it's actually gonna have more points of intersection than that. And we gotta keep it within this domain or it doesn't make sense. So make sure that you've got your domain. All right, Vincenzo?
Yeah.
You think you got it?
Yeah, I got it.
Guaranteed test question?
Yep. I just messed up the first equation for some reason when I first did it, and that's what I messed up.
Okay, what's your next question?
13, what do you mean by the graph is tangent to the x-axis?
Okay, so let's look at 13.
Same pages and we should have been.
That's on 13. It doesn't require it.
We got a great meeting there.
Alright, so let's graph. Hey, I'm really not sure what all this noise is about, but I should hear it. Everybody should be riveted on me, right? Let's get focused. We have a test tomorrow. Okay, so let's go ahead and sketch this problem. It says to do that anyway. And in sketching it, you're going to answer every single question that's asked. What's the first thing you're going to do when you sketch it?
X-axis or x-axis?
You're going to put x-intercepts at 1,
-4,
-4, and 5.
No, add all the trees.
Those right there are the x-intercepts. Those dots are the x-intercepts. Okay? How do we find a y-intercept?
Put in here.
Plug in 0 for x. So -1, 16, -5. So I got 80. Okay? Now let's sketch it. let's connect these dots. Now, we aren't in the habit of putting the y-intercept on there. I mean, it's fine, it's fine. But we haven't used that before to graph. Instead, we've counted up the x's
Yep.
and decided that there are 4 of them. 4 is even.
Yeah.
Even is up, up.
Yes.
There's no negative out here to mess it up, so I'm gonna start up here. Now, when I get to this point, I have to make a choice.
Bounce.
This is gonna
I got
bounce.
one bounce.
That's called a point of tangency. It just, whoop, that's your point of tangency right there.
Yeah.
Bounces off.
Wow.
It comes up, it's gonna grab that point, come down. What's it doing when it gets here?
Is it going through?
So it looks something like that.
Yeah.
All right, that, when you are tangent to something, think about it in geometry, when you are tangent to something, you just touch it.
I hate geometry. Please don't talk.
So what would you put as the answer for, like, negative 4, 0?
Negative 4, 0.
Is that the question?
Yeah.
What's the tangent?
Now, what's the tangent? Where is it?
Oh, where?
Negative 4, 0.
Oh, that's gonna test. That's gonna test.
All this is the test.
Oh my gosh.
You need to know how to do this.
She has the next one.
All right, who else? You should have stuff circled from when you were working the other day. I hope you were working the other day. Ronan? 4. Solve.
Oh, I was wondering about that one too, like the format, how you wanna answer, like on a line graph.
So, this says solve. So I'm gonna add 8 all the way across.
Yeah.
And divide by 4 all the way across. So I have 3 halves and 7 halves. That would be fine. This is a multiple choice question, so the answer may be written like that, and it may be written in interval notation. But that is essentially the answer. All right, what else? Did you even try it? No.
Dang.
I know.
What did you guys do when I was gone?
Play games.
Yeah.
Who just
I
said play
can
games?
tell.
Who said that?
Who just said play games?
Which one did you say? There's more than one way to do every problem, this one included. So what occurs to you when you look at it?
Make the 8 negative.
So 4x minus 3 equals 8, 4x minus 3 equals negative 8.
Yes.
Solve each equation and that's your answer.
But no, you get to check something.
Nope.
Okay.
I mean, it's always a good idea to check, but you don't have to. There's no extraneous going on with a problem like this, no. All right. All right, I'm just gonna pick some because I'm a little bit frustrated that we don't have a little more participation here. Number 25 and 6. How do we solve this? So 4 squared equals 3x plus 1, and then we solve it, okay? How do we solve the one next to that?
We cancel it.
No.
You do blue.
No, the 2 goes on the 8.
There you go, that's step 1.
The 2 goes on the 8, so
You
then
need
x
to
equals-
take the 2 off the front and turn it into an exponent. Then, because it's log equals log, we can drop them and x equals 64. What does that look like?
That looks like hold on.
Now, if you don't know what it looks like, what can you always do? What will always work?
Graphing it.
This is a no calculator problem. This is a no calculator problem, so the idea is you're gonna grab it by hand. So you can always set up a T-chart and plug points.
Yeah.
My hope would be that you know what an exponential looks like. What does an exponential look like?
It looks like a half a rebel.
It looks like this, doesn't it?
Half a rebel.
And then if we're going to add 2 to the x.
Goes to the right two. Left two,
Left
left
2.
two.
It moves left 2. Add
not
2 to
Y.
the x. Now, if you move it left 2, is that gonna change the fact that this is still an asymptote?
No, it's not.
No, it isn't. It's just gonna be left 2.
Oh.
But again, if you don't know that, you can say, okay, what happens if I put in 0?
9.
I get 9. What happens if I put in 1? Okay, I think I'll go the other way. What happens when I put in negative 3? Negative 2.
1.
1. There you go. And you got enough points now, you can just plot them and connect the dots. Right? That will work every time.
If you were to ask like domain or range, wouldn't like the domains that you refer to
Nope.
as like a
Nope, nope, it's going all the way to the left and all the way to the right. If you add 2 to infinity, then you'll change, it's still infinity. So no, that has nothing to do with either one, it won't change either one. Now, this would change the range, if you did that, because that's gonna take the picture and lift it up, so that'll change the range.
27.
Alright, I need a formula for this, which one is it? Is it PERT or the other one?
The other.
The other
That's
one.
compound interest.
Yeah. So I wanna end up with 1, 2, 3, 4. I wanna start with 987.
1 plus
My
0.0.
interest rate is 0.045.
Over 1.
Annually is 1, and I wanna know how long it's going to take. So, step 1,
By 987.
divide by 987.
You log on both sides.
This is actually an easy one to combine
Yeah.
if you wanted to, but, yeah, so now I'm gonna log both sides.
T log.
Pull the exponent out in front,
1.0.
and then divide by that one, right? So it's gonna be the log of this big fraction divided by the log of 1.045.
Absolutely.
So log, 1, 2, 4. So it should be about 5.07 years.
Yeah.
All right, over there on the additional side there, number 7 says, where are we increasing? Increasing means going up. So, looking at the picture,
Negative 2, negative 1.
it looks like I'm going up from here to here. And then I'm also going up from here to here, right?
Yep.
So the intervals where I'm going up are -2 to -1, and from 2 to 3. Those are the intervals where I'm going up.
Would it not be brackets? It's points.
There is, debate with that, because at the points, it really isn't increasing, it's stationary. So normally we use open intervals, but if someone put closed, I wouldn't have it wrong.
What's your calculator?
Alright, let's see.
Can we do one of the bacteria ones?
It's like that's just per.
I still like to do.
Alright,
28 says, how long will it take 504, 503, boiled into So, problem 28, I use my PERC formula, and I'm looking for T. Remember, never, ever, ever put a percent into the problem.
Okay.
So it has to be written as .023. So now I'll write
Hit L on both sides.
ln both sides, use that,
5 by 0.7.
ln my fraction divided by 90. Letter 1B on that extra practice in there. Talks about the asymptotes. What are the asymptotes?
Just for it. What'd you get for the answer?
I didn't type it in, it's on the answer sheet though. Okay, so. Alright, so the question says find all the asymptotes. So they'll be horizontal and vertical. Where do the vertical asymptotes come from?
The bottom.
Come from the denominator. So, I need to factor my denominator. And I can see that I'm gonna have two vertical asymptotes.
Plus minus
They're
two.
going to be at -2 and positive
Can you,
2.
will you accept just plus or minus two?
It's probably a multiple choice question, you just wanna match it up. And then y equals, now, to find my horizontal, I need to box these in, but they don't match. So I put a 0 where I have something missing, there's no squared on the top. Now I can box them in, and I can see that my horizontal asymptote is y equals 0.
No slant.
Wait, would that be, why would it be 1?
Because it's a zero.
It's
Oh,
0
so-
over 1. Is it really wrong?
Okay. Number 10. On the beginning of the sheet.
E three, E to the 3x plus 4.
We went over the.
So number 10 here says, we got a function, and we need This is getting exhausting, this constant chatter. I am not one of those nice teachers. You flunk it, you flunk it. You never the E, you never the V. Alright, so the question's two-part question, what are the possible rational roots, the PRRs? Alright, so factors of 27 over factors of 3. Now we need to list those. This is not gonna get you full credit, alright? You need to list them. So I like to just put them all over 1, because that just leaves them the same. Right, all those over 1.
1/3.
Then
2
I
and
start
1/3.
putting them over, well, that makes 9, 3, 1, 1/3.
Oh, shoot.
So there is a list, it's okay to put plus or minus out there on, that's the list of numbers. Now, we need to find the actual roots. These are the possibles, I forgot pieces. possible. How do we find the actual ones? Well, you can definitely use synthetic division. So you pick a number from that list, and you start dividing, and you keep dividing until you get a remainder of zero. Now, I heard somebody already say though, looking at the problem, you could also get your roots by grouping them. That groups. So if you wanted to group it, there we go, that groups. And then you have your common factor, and then you have 3x squared plus 27. What can we do with the 3x squared plus 27?
Take a 3 out.
Take a 3 out,
And you can't do anything else.
and you can't do anything else because that is not a
Negative.
minus, right, that's a plus. So, what are the roots? Well, one of the roots is
-1.
-1.
Plus minus 3.
Be careful.
Yeah.
X squared equals negative
So
9.
plus
Oh.
So plus or
3i.
minus 3i.
I would get that wrong.
The square
What about the
root.
3? What about the 3 and 0?
Huh?
What about the 3 and the 5?
Is there an X attached to it? Not a root. X, zeros come from X's.
Came with that.
Okay. Number 12. Find the vertex of this parabola. First of all, do you recognize it's a parabola?
Yeah.
Yes.
Lost second time.
I'm so ready.
Alright. We have office hours after school
I'll be there.
until 3.
Oh yeah, you're gonna be all set. I heard you missed the sport we were talking about. Oh.